Welcome to our exploration of ethical considerations and scientific methods within biomedicine. As science advances, the importance of ethics becomes even more pronounced. In biomedicine, where research directly impacts human lives, ethical guidelines serve as a crucial foundation. This video will guide you through the core ethical principles, real-world dilemmas, and the frameworks that help scientists make responsible decisions. We'll also look at how these considerations shape research design, data collection, and the application of findings. Let's begin by understanding why ethics are so vital in biomedical research and how they ensure the well-being of both participants and society. Biomedical ethics refers to the moral principles that guide research and practice in the life sciences. These principles are designed to protect human dignity, promote fairness, and prevent harm. In the context of scientific methods, biomedical ethics addresses issues such as informed consent, confidentiality, and the responsible use of technology. By adhering to these standards, researchers ensure that their work not only advances knowledge but also respects the rights and welfare of individuals. Understanding biomedical ethics is the first step toward conducting research that is both innovative and socially responsible. History of biomedical research is filled with both groundbreaking discoveries and ethical controversies. From early clinical trials to modern genetic engineering, each era has faced unique moral challenges. Notable historical events such as the Tuskegee syphilis study and the development of the Nuremberg Code have shaped current ethical standards. These milestones remind us that ethical lapses can have lasting consequences, emphasizing the need for vigilance and continuous improvement in research practices. By learning from the past, we can better navigate the ethical complexities of today's biomedical science. The heart of biomedical ethics are several core principles: respect for persons, beneficence, non-maleficence, and justice. Respect for persons involves recognizing the autonomy and dignity of all participants. Beneficence requires researchers to maximize benefits and minimize harm. Non-maleficence is the obligation to avoid causing harm, while justice ensures fair distribution of the benefits and burdens of research. These principles serve as the foundation for ethical decision-making in scientific methods, guiding researchers as they design and conduct studies. Informed consent is a cornerstone of ethical biomedical research. It means that participants are fully aware of the nature, risks, and benefits of a study before agreeing to take part. Researchers must provide clear, understandable information and ensure that consent is given voluntarily without coercion. This process respects individual autonomy and protects vulnerable populations. Informed consent is not just a formality, it's an ongoing dialogue between researchers and participants, ensuring transparency and trust throughout the study. Protecting the confidentiality and privacy of research participants is essential in biomedicine. Researchers must safeguard personal data and ensure that information is only used for its intended purpose. This involves secure data storage, restricted access, and careful handling of sensitive details. Breaches of confidentiality can lead to loss of trust, emotional harm, or even legal consequences. By prioritizing privacy, scientists uphold the dignity of participants and maintain the integrity of their research. Every biomedical study involves weighing potential risks against anticipated benefits. Ethical research requires a thorough risk-benefit analysis to ensure that the possible advantages justify any harm or discomfort to participants. This assessment must be ongoing, as new information can change the balance. Researchers are responsible for minimizing risks and maximizing benefits, always keeping the welfare of participants at the forefront. A transparent risk-benefit analysis builds public confidence in scientific methods. Justice in biomedical research means ensuring that the benefits and burdens of research are distributed fairly. This principle addresses issues such as equitable participant selection and access to new treatments. Researchers must avoid exploiting vulnerable groups and strive for inclusivity. Fairness also extends to the allocation of resources and the sharing of research outcomes. By upholding justice, scientists contribute to a more equitable healthcare system and foster trust in the research community. Certain groups, such as children, the elderly, or those with cognitive impairments, are considered vulnerable in biomedical research. These individuals may have limited capacity to provide informed consent or may be at greater risk of harm. Ethical guidelines require additional protections for vulnerable populations, including careful risk assessment and the involvement of legal guardians or advocates. Researchers must be especially vigilant to ensure that these groups are not exploited and that their rights are fully respected. Animal studies play a significant role in biomedical research, but they also raise important ethical questions. Researchers must justify the use of animals, minimize suffering, and use alternatives whenever possible. Ethical frameworks such as the 3Rs, replacement, reduction, and refinement, guide scientists in conducting humane animal research. Oversight committees review protocols to ensure compliance with ethical standards. By respecting animal welfare, researchers demonstrate their commitment to responsible science. Protecting human subjects is a top priority in biomedical research. Institutional review boards, IRBs, or ethics committees review study protocols to ensure that risks are minimized and participants' rights are protected. These bodies evaluate informed consent procedures, risk-benefit analyses, and data privacy measures. Their oversight helps maintain high ethical standards and public trust in scientific research. Researchers must work closely with these committees to address any ethical concerns before, during, and after a study. Maintaining data integrity is essential for ethical scientific research. This means collecting, storing, and analyzing data accurately and honestly. Researchers must avoid practices such as data fabrication, falsification, or selective reporting. Transparent data management ensures that findings are reliable and reproducible. Ethical guidelines require researchers to keep detailed records and make data available for verification when appropriate. Upholding data integrity strengthens the credibility of biomedical science. Conflicts of interest can arise when researchers have financial or personal interests that could influence their work. Ethical guidelines require full disclosure of any potential conflicts to ensure transparency. Managing conflicts of interest helps prevent bias and maintains the objectivity of scientific research. Institutions often have policies and oversight mechanisms to address these issues. By openly addressing conflicts, researchers protect the integrity of their studies and maintain public trust. Publication ethics govern how research findings are shared with the scientific community and the public. Researchers must report results honestly, give proper credit to collaborators, and avoid plagiarism. Ethical publication also involves correcting errors and retracting studies when necessary. Journals and institutions play a key role in upholding these standards. By following publication ethics, scientists contribute to the advancement of knowledge and the credibility of biomedical research. Peer review process is a critical component of ethical scientific publishing. It involves independent experts evaluating research for quality, validity, and ethical compliance before publication. Peer review helps identify errors, biases, or ethical concerns that may have been overlooked. This process ensures that only high-quality, ethically sound research enters the scientific literature. Researchers benefit from constructive feedback, while the public gains confidence in published findings. Plagiarism and scientific misconduct undermine the integrity of biomedical research. Plagiarism involves presenting someone else's work as your own, while misconduct includes data fabrication, falsification, or unethical behavior. Institutions have strict policies to detect and address these issues. Researchers are expected to uphold the highest standards of honesty and accountability. By preventing misconduct, the scientific community protects its reputation and ensures that research benefits society. Genetic research offers tremendous potential for understanding disease and improving health, but it also raises unique ethical challenges. Issues such as genetic privacy, discrimination, and the use of genetic information must be carefully managed. Researchers must obtain informed consent for genetic testing and ensure that data is protected. Ethical guidelines help prevent misuse of genetic information and promote responsible innovation in this rapidly evolving field. Stem cell research holds promise for treating a wide range of diseases, but it also presents ethical dilemmas. The use of embryonic stem cells, in particular, raises questions about the moral status of embryos. Ethical frameworks require careful consideration of the sources of stem cells and the potential benefits versus ethical concerns. Oversight committees review protocols to ensure that research is conducted responsibly and transparently. Clinical trials are essential for testing new treatments, but they must be conducted ethically. This includes obtaining informed consent, ensuring participant safety, and providing access to the best available care. Researchers must also be transparent about potential risks and benefits. Ethical oversight by review boards helps protect participants and ensures that trials are scientifically valid. By following ethical guidelines, clinical trials contribute to medical progress while safeguarding human rights. New technologies, such as artificial intelligence and gene editing, are transforming biomedicine. However, they also introduce new ethical challenges. Researchers must consider the implications of using these tools, including potential risks, biases, and unintended consequences. Ethical frameworks are evolving to address these issues, ensuring that innovation does not outpace responsibility. By anticipating ethical concerns, scientists can harness technology for the greater good. Biomedical research is a global endeavor, and international guidelines help harmonize ethical standards across countries. Documents such as the Declaration of Helsinki and the CIOMS guidelines provide frameworks for ethical research worldwide. These guidelines address issues like informed consent, risk-benefit analysis, and the protection of vulnerable populations. By following international standards, researchers promote collaboration and ensure that studies are ethically sound, regardless of location. Ethical research in biomedicine requires sensitivity to cultural differences. Researchers must respect local customs, beliefs, and values when designing and conducting studies. This includes adapting informed consent procedures and ensuring that research is relevant and beneficial to the community. Cultural sensitivity helps build trust and fosters meaningful partnerships between scientists and participants. By honoring diversity, researchers enhance the ethical quality of their work. Engaging with the community is a key aspect of ethical biomedical research. Researchers should involve community members in the design, implementation, and dissemination of studies. This approach ensures that research addresses real needs and respects local priorities. Community engagement also promotes transparency and accountability, helping to build lasting relationships between scientists and the public. By working together, researchers and communities can achieve better health outcomes. Transparency is fundamental to ethical scientific methods. Researchers must openly share their methods, data, and findings with the scientific community and the public. This openness allows others to verify results, replicate studies, and build on previous work. Transparency also helps prevent misconduct and fosters trust in science. By being transparent, researchers demonstrate their commitment to honesty and accountability. Ethics committees such as institutional review boards play a vital role in overseeing biomedical research. They review study protocols to ensure that ethical standards are met and that participants are protected. Committees assess informed consent procedures, risk-benefit analyses, and data privacy measures. Their oversight helps maintain public confidence in research and ensures that studies are conducted responsibly. Researchers often face ethical dilemmas where there is no clear right or wrong answer. These situations require careful consideration of competing values and interests. For example, balancing the need for scientific progress with the obligation to protect participants can be challenging. Ethical frameworks in consultation with colleagues or ethics committees can help guide decision-making. By thoughtfully addressing dilemmas, researchers uphold the integrity of their work. Whistleblowing is the act of reporting unethical or illegal behavior in research. It plays a crucial role in maintaining ethical standards and protecting participants. Institutions should provide safe channels for whistleblowers and protect them from retaliation. Encouraging a culture of openness and accountability helps prevent misconduct and ensures that ethical breaches are addressed promptly. Ongoing education and training in ethics are essential for all researchers. Training programs help scientists understand ethical guidelines, recognize potential issues, and respond appropriately. Institutions should provide regular opportunities for learning and discussion. By staying informed, researchers can navigate complex ethical situations and uphold the highest standards in their work. Patient advocacy is an important aspect of ethical biomedical research. Advocates represent the interests of participants, ensuring that their rights and needs are prioritized. Researchers should collaborate with patient advocates to design studies that are respectful and responsive to participants' concerns. This partnership helps create research that is both scientifically valuable and ethically sound. Sharing data is vital for scientific progress, but it must be done ethically. Researchers should obtain consent for data sharing, protect privacy, and ensure that data is used responsibly. Ethical data sharing promotes collaboration and accelerates discovery while safeguarding the rights of participants. Clear policies and agreements help guide responsible data sharing practices. Open science movement encourages researchers to make their methods, data, and findings accessible to all. This approach promotes transparency, reproducibility, and collaboration. However, open science also raises ethical questions about privacy, intellectual property, and the potential for misuse. Researchers must balance openness with the need to protect participants and respect proprietary information. Biomedical researchers have a social responsibility to ensure that their work benefits society. This includes addressing public health needs, promoting equity, and considering the broader impact of research. Ethical guidelines encourage scientists to engage with communities, policymakers, and other stakeholders. By acting responsibly, researchers contribute to the common good and enhance the value of their work. Biomedical research can have environmental impacts such as waste generation or resource use. Researchers should consider the environmental consequences of their work and strive to minimize harm. This includes using sustainable practices, reducing waste, and considering the long-term effects of research activities. Environmental ethics are an important part of responsible science. Ethical publication practices are essential for maintaining the credibility of biomedical research. Researchers must avoid duplicate publication, give proper credit, and disclose any conflicts of interest. Journals have policies to detect and prevent unethical practices. By following publication ethics, scientists ensure that their work is respected and trusted by the community. Collaboration is vital in biomedical research, but it must be conducted ethically. Researchers should communicate openly, share credit fairly, and resolve conflicts respectfully. Ethical collaboration fosters innovation and ensures that all contributors are recognized for their work. Clear agreements and mutual respect are key to successful partnerships. Funding sources can influence the direction and outcomes of biomedical research. Ethical guidelines require transparency about funding and the avoidance of undue influence. Researchers should disclose all funding sources and ensure that financial interests do not compromise scientific integrity. By managing funding ethically, scientists maintain the trust of the public and the research community. Commercializing biomedical research can bring new treatments to market, but it also raises ethical questions. Researchers must balance the pursuit of profit with the obligation to serve the public good. This includes fair pricing, access to innovations, and transparency about commercial interests. Ethical commercialization ensures that scientific advances benefit society as a whole. Effective communication is essential for ethical biomedical research. Researchers must present information clearly, avoid exaggeration, and communicate risks honestly. This applies to interactions with participants, colleagues, and the public. Ethical communication builds trust, supports informed decision-making, and helps prevent misunderstandings or misinformation. Mentorship plays a crucial role in fostering ethical research practices. Experienced scientists should model ethical behavior, provide guidance, and support the professional development of trainees. Mentors help instill a culture of integrity and responsibility, ensuring that the next generation of researchers upholds high ethical standards. Use of technology in biomedical research, from electronic health records to advanced analytics, brings both opportunities and ethical challenges. Researchers must ensure that technology is used responsibly, with attention to privacy, security, and potential biases. Ethical technology use supports accurate research and protects participant rights. Emergency situations such as pandemics or natural disasters require rapid biomedical research. However, speed must not compromise ethical standards. Researchers must still obtain consent when possible, protect vulnerable groups, and ensure that studies are scientifically valid. Ethical emergency research balances urgency with the need to safeguard participants' rights. Global health research often involves working in diverse settings with varying resources and needs. Ethical considerations include respecting local customs, ensuring fair access to benefits, and addressing health disparities. Researchers must collaborate with local partners and prioritize the well-being of all communities involved. Ethical global health research promotes equity and shared progress. Ethical standards in biomedical research are not static, they evolve as science and society change. Researchers must stay informed about new guidelines, emerging issues, and best practices. Continuous improvement ensures that ethical considerations keep pace with scientific innovation. By embracing lifelong learning, scientists uphold the highest standards of integrity. Examining real-world case studies helps illustrate the complexities of ethical decision-making in biomedicine. These examples highlight both successes and challenges, offering valuable lessons for researchers. By analyzing case studies, scientists can better anticipate ethical dilemmas and develop strategies for responsible conduct. Learning from experience strengthens the ethical foundation of biomedical research. Conclusion: ethical considerations are central to scientific methods in biomedicine. From informed consent to data integrity, each aspect of research is guided by principles that protect participants and promote the common good. As science continues to advance, new ethical challenges will emerge. By staying committed to ethical standards and continuous improvement, researchers can ensure that biomedical science remains a force for positive change in society.